thinking about what regulates the productivity of temperate crop production systems, the law of the minimum and maximum can be very helpful in thinking through, what's going on in the field. So in this video, what we'll do is talk about both of these laws in turn and give you some examples of how they apply to actual crop production. So let's start with Liebig's law of the minimum. So Liebig was a German scientist, and in 1843, so a couple hundred years ago, he put to paper this law of the minimum, where he says, look, there's lots of things that impact crop yield, but in a farm field, there's only one thing that limits crop yield. It is the factor that is in greatest limitation, what he calls the limiting factor. And so what you can see here is an illustration of that. Imagine like a wooden bucket with different wood staves, and yield is the water, that's held in the bucket. It doesn't matter how tall the tallest stave is, how much you have of one nutrient. It really matters what the lowest stave is. So what is the most limiting factor? And so in this example, as you can see, it would not be, for example, sulfur or zinc or copper or any soil conditions. It would be whatever was that low stave that water was leaking out from. And so according to Liebig's law of the minimum, yield can only increase if that factor is corrected. It makes no sense to correct any other factor other than the one that is limiting. And so what Liebig's law kind of leads to is a management philosophy that says we need to aim at correcting the most limiting factor one by one until there are no remaining limiting factors. So we go the most limiting factor, correct that, then the next limiting factor, correct that, and so on and so forth. Simple enough. So what you see here is a soil test. This is from SGS Labs in Guelph, but any OMAFRA accredited soil test lab, if you send it in an agricultural soil sample, they'll send you basically a report that looks the same. So I sent in a number of samples here and asked for a bunch of different soil tests, from pH all the way to ammonium, looking at cation exchange capacity, Kmg ratio. You'll take a soil science course to understand these tests, but the two I want to bring to your attention, two of these tests, or the results of two tests that we're going to talk about, are the phosphorus, or P, sodium bicarbonate test, and the potassium acetate test, which measured plant available phosphorus, the sodium bicarbonate did, and then the potassium acetate, the acetate test measured plant available potassium. And I use this test to help me figure out how much fertilizer I actually need to apply to my crops in these fields. And this illustrates Liebig's law of the minimum. So let me zoom into the results from the sodium bicarb test that tests plant available phosphorus. So I go to the OMAFRA agronomy guide for field crops. Let's just say I'm growing corn here. And I say, based on my soil test, how much fertilizer should I apply? And this is basically saying, the soil test is basically going, if your phosphorus is below 31 ppm, then it will be a limiting factor to your corn production. And so, below 30 ppm, you need to apply phosphorus. And the lower your sodium bicarb score, the lower the ppm, the more phosphate you require for your corn. I can also do the same for my potassium soil test results. So I go to the OMAFRA agronomy guide. Let's say again I'm growing corn on this field, and I compare my potassium soil test results to this recommendation chart. So OMAFRA does not recommend applying any potassium fertilizer if your soil test is above 120 ppm. Anything below 120 ppm will have a recommendation associated with it to apply some potassium. But all these test scores say that I have more than enough potassium based on this recommendation, and so there is no need at all to apply potassium. So going back to this overall soil test, I won't go through everything else, all the other nutrient tests, but in summary, the only nutrient that was limiting based on the soil test was phosphorus. And so the application of the law of the minimum here is quite simple and straightforward, right? I would only be applying phosphorus fertilizer to this corn crop because there are no other limiting factors. The other nutrients are not limiting. So the law of the maximum, coined by a German scientist by the name of Mitscherlich in 1909, applies in high-yielding environments. It does not apply in areas where there's one or two factors that are severely limiting to crop yields. Okay, so in high-yield environments, high-yield potential areas, I would categorize most of southern Ontario as falling into this category. In these high-yielding environments, each factor that goes into crop production is probably limiting yields by less than 10% or so. Okay, so we can think of, well, there's not a huge phosphorus deficiency, but if you added a little bit more phosphorus, maybe you would increase yields by about 5 to 10%, or maybe there's some disease pressure. So if you used, let's say, a seed treatment, you would increase yields by about 5 to 10%. So correcting any one factor is only going to increase yields by a very small amount. Productivity is not going to go up by very much if you, for example, add a seed treatment. But what Mitscherlich's law of the maximum says is that at very high yield levels, the efficiency of all factors, all factors that go into crop production, are going to increase as any other one limiting factor is corrected. And what that means is the final result or yield is greater than the sum of the effects because each effect multiplies the effect of every other factor. And I'm going to give an example that explains what I'm talking about. But according to this law of the maximum, crop management should aim at correcting multiple factors together to obtain a multiplicative yield effect. So this is data from a sugarcane experiment in Pakistan. This was an on-farm experiment. I know this is not a temperate cropping system, but it really illustrates well this law of the maximum. So on this plantation, they wanted to increase yields, increase profitability, and so they did 3 different experiments where they compare their typical farming practices to adding micronutrients, adding a fungicide, and adding a seed treatment, all in 3 different experiments. And then they looked at what their typical yield was without that factor compared to what they attained with, whatever that micronutrient or that seed treatment. And you can see here what they found. For example, that micronutrient limitation, they only achieved 91% of their attainable yield, right? Because with that micronutrients, they actually had somewhat of a higher yield. So that micronutrient was limiting yield by about 9%, and so on and so forth. So you might think, okay, well, this is not a huge yield reduction, right? 9%, 13%. And so maybe it doesn't make sense to, add a fungicide or a seed treatment. It might not be financially or economically worthwhile. But when you think about what is the total yield reduction of all of these 3 factors, which admittedly are not limiting yields by very much, well, what they found was that their on-farm yield, right, when you multiply these factors out, the total yield reduction without these factors caused on-farm yields to be only 69% of attainable yields with those factors. All right, so that becomes a pretty big number, right? You're only hitting about 69% or 70% of your attainable yield due to these 3 limiting factors. And that's a number that's true for most temperate cropping systems throughout North America. On-farm yields are about 70% of potential attainable yields. And that's, comparing the highest on-farm yields that are recorded in a county and comparing all other farm yields to the 10 highest yielding on-farm yields. You end up with about this 70% of potential yield. So in summary, this law of the maximum states that in high yield potential situations, in those environments, factors are limiting yield by only about, 5-10%. So correcting any single factor is not as powerful as correcting multiple factors all at the same time, because you have this multiplicative effect where every factor, the efficiency of every factor is increased the more the other factors are corrected. And so let's look at some yield contest winners in the United States and see what their production practices are, because thinking about this law of the maximum, it starts making sense what they are doing. To think more about how this law of the maximum works in practice, we're going to go over the farm practices of the current world record holder for corn yield in an irrigated system. It's a farmer named Dave Hula who farms in Virginia. There's a YouTube video that kind of gives an overview of his operation. But we're going to go over the management practices that gets him to, over 500 bushels per acre yield. In Ontario, the average corn yield is about 180 bushels an acre, so this is significantly higher than that. So this is all taken from magazines that, interview Dave and ask him to describe his management practices. He's in a no-till system, irrigated like I mentioned, fine sandy loam. In the video linked in the last slide, he talks quite a bit about soil health, and I'll just let you read some of these management practices he does. So after reading through these slides, it's pretty apparent that what Hula is doing to get that 500 bushels is adjusting multiple different factors by just a little bit. On these high yield contest winners farms, there's probably not one major limiting factor. They're adjusting multiple things a little bit, and that's creating a multiplicative effect.